All right. What about if we're looking at 1 from the left here? Okay. So how do we go about evaluating this? We could graph it. There's no algebra to do with it, so we've either got to graph it or we've got to look at it analytically. It's your decision on how you would want to do that. I'm going to do this analytically, I think, or excuse me, I'm going to do this numerically by picking numbers a little bit smaller than 1 because I can do that in my head here. The limit, well, I'm not going to take the limit. I'm going to say what is the function value at a number that's a little bit smaller than 1. What about if I put 0.9 in here? So I'm going to get 0.81 minus 3 times 0.9 would be 2.7. And I'm not really worried about the number as much as I am what is the sign of the number. So in the numerator, 0.81 minus 2.7 is going to give me a negative number. And 0.9 minus 1 is going to give me a negative number. Okay, since I know that there's a vertical asymptote at 1, I know the answer is either infinity or negative infinity. Well, a negative divided by negative tells me that it's a positive, so the solution must be positive infinity. What if we look at the same problem and look at it from the right side? So again, I'm going to look at what is f of 1.1. Well, at 1.1, I've got 2.2 minus 3.3, which that's going to give me a negative number in the numerator. 1.1 minus 1 is going to give me a positive number in the denominator. Negative divided by negative tells me my negative divided by positive tells me my answer will be negative. I know the limit should be infinity or negative infinity because at 1 the denominator is 0, so my final answer here is negative infinity. So just think about that, what you know about the graph now because of these two things. Even though we have no idea what the graph looks like unless we use our calculator, we know that when we come to x equals 1 over here, that we've got an asymptote, so the function is not defined there. We know if we take a number larger than 1, like 1.1, the function is down here at the bottom, is approaching negative infinity. And we know that if we take a number smaller than that, the function is going to be up here. So suddenly, by knowing a little bit about calculus, by being able to evaluate the limits, we've got some idea of what's happening with this graph around this point. And as we learn more and more, we'll be able to tell you more things about the graph simply by evaluating limits at particular points. What's the limit as x approaches 0 of this function here? Well, a strange looking function compared to what we've normally dealt with. Let's break it up. Because of the plus sign, we can rewrite this as two different limits. The limit as x approaches 0 of 5 plus the limit as x approaches 0 of 1 over x squared. Well, remember, first thing we always try is to plug in. There's no number to plug in here, so this limit is a constant number. The first part is 5. What about the second part? Well, if we plug 0 in, the denominator becomes 0. So what does that tell us? That tells us that our limit is either infinity or negative infinity. So we need to look at it from both the left side and the right side. If you take a number a little bit smaller than 0 and put it in here and square it, what kind of number do you get out? A positive number. So if we're looking at this limit as x approaches 0 from the left, we're going to get 1 over a positive number, which is going to give us an answer of infinity. Because even though it's a positive number, it's a very small number. And 1 divided by a very small number will give us a very large number. What about if we try to evaluate this limit as x approaches 0 from the right side? A number a little bit larger than 0. It's still a very small number. It's still a positive small number. So we're going to get infinity again. So now from the left side, this function's approaching infinity. from the right side, this function's approaching infinity. So this limit does exist. This limit is infinity, and infinity plus number 5 just gives us an overall limit of infinity for this particular problem. So the answer for this problem is that the limit does exist and the limit is infinity. Well, if we look at this problem as x approaches 1 from the left, okay, in the numerator we're going to get 1 plus 1 is 2. The denominator, if we put 1 in here, the cotangent at pi, remember the cotangent is cosine over sine, so that's going to give us what appears to be an undefined thing here, right? Let's see if we can rewrite this and come to any conclusions here. The limit as x approaches 1 from the left of x squared plus 1, we could write that as the cosine of pi x over the sine of pi x, couldn't we? Well, we could rewrite that so that we don't have complex fractions as well. If we leave the numerator like it is, we're going to flip the denominator over. We've got the sine of pi over x over the cosine of pi over x. So now can we evaluate this? Well, this first limit here, if we look at just this first quantity right here, we're going to get the number 2 out. What's going to happen when we put in 1 over here? The sine at pi, the sine of pi is 0. The cosine at pi, because we're putting 1 in, the cosine at pi is -1. So we can evaluate this and get an answer of 0 out. The limit as x approaches 0 from the right of this function. So let's look at this. Again, we know that the limit of just the number 3 is 3. So I'm going to rewrite the 3 outside of the limit. I'm going to say x approaches 0 from the right. And I'm going to rewrite cotangent as cosine of x, over the sine of x. Okay? So if we put 0 in for the denominator, the sine of 0 is 0. So we can't do that. Let's put in a number close to it. And notice we're from the right. So we're talking about a number that's just a little bit larger than 0. If you go back and remember what the cosine function looks like, if we graph it, it's going to start off at 0 and go up. So these numbers right here are what we're talking about. We're talking about numbers that are just a little bit larger than 0 in the x direction. From a y perspective, they're going to be a positive number. So this is going to be a positive number in the top, 1, over a positive number in the bottom. This number is going to be about 1. This is going to be a positive number that's about 0. So we're going to have a number divided by a really small number. They're both going to be positive. So the limit should be infinity because we've got a positive number divided by a positive number. So our answer should be infinity.